In order to find the whole vertical asymptote domain, the first thing we'll start off with finding the domain. How are you supposed to find the domain for this function? What are you supposed to do? The domain, you have to do what? Factor what? The domain is always set the bottom equal to 0. So you're going to set the denominator equal to 0. And remember, we're talking about rational functions now. A rational function is anything that can be written as f of x is equal to some numerator polynomial divided by a denominator polynomial. So it's a numerator polynomial divided by a denominator polynomial. And the problem with this, why can it not be 0? Why can the denominator not be 0? Because you can't divide by 0, right? You can't divide by 0. So in order to do that, to find the domain, here's what you're going to do. The domain is set the bottom equal to 0 first. So you're just going to say x squared plus 3x minus 28. And we'll say it does not equal 0. We do not want it to equal 0. So we're going to take out the values that make it equal 0. How do I factor this? Help me out. How do I factor this? Good. X plus 7 and x minus 4 does not equal 0. Factors of 28 that add to 3 are 7 and negative 4. So that means that x is not equal what two values? 4 and negative 7. Negative 7 and 4. So the domain of this function is going to be the values, every value except negative 7, and every value except 4. So here's how you write your domain. Understand that? Now, in order to find the vertical asymptotes, how do we find vertical asymptotes? What do we do to find a vertical asymptote? Assuming I just shy this morning. So, how do we find a vertical asymptote? A vertical asymptote was the... Let's talk about what is an asymptote, bro? Let's start there. What is an asymptote? It's an imaginary line that the function never touches, right? And it exists because this bottom part is going to be 0. Does everybody understand that? So one of the values is going to make this bottom part 0. We've already found two parts that make the bottom part 0. Does everybody understand that? So an asymptote is an imaginary line that the function f of x approaches but never touches. And it occurs because the bottom is 0. So in order to fix that, here's what you're going to do. To find what value makes it 0, we already found the values that make it 0, but the problem with that is this. There may be factors in the top that can cancel out factors in the bottom. So in order to find vertical asymptotes, you're going to have to find what we call holes first. In order to find a hole, the first thing you're going to do is factor the original expression. So how do we factor x squared minus x minus 56? Help me out. What are the factors of 56 that add to negative 1? Yeah, x minus 8 and x plus 7 at the top. The bottom is what? We've already factored that into x. Yeah, x minus 4 and x plus 7. You've already told me that the values of negative 7 and 4 make the bottom 0, right? Everybody understand that? We looked at that through finding the domain. But here's what happens now. When I factor, I see that this x plus 7 term is common to top and bottom, right? So what can I do to that? Cancel it out. So the second step after you factor, when you find a hole, you're looking for terms that cancel. You're looking for terms to cancel. That means that the hole is going to occur here. This is where the hole will occur at. And we get a reduced form of this equation. So this is x minus 8 over x minus 4. And what this factoring process is just like saying that 4/8, what does 4/8 equal? 1/2, right? 4/8 equals 1/2, because what are you doing to it? You're reducing it by a factor of 2. Y'all got that? Same thing, x squared minus x minus 56 over x squared plus 3x minus 28 reduces by a factor of what? X plus 7, because it's common to both terms, right? So what does that really equal? X minus 8 over x minus 4. This is called the reduced form of that equation. If you can reduce a fraction, you're going to reduce a fraction. And you can do it in this step too. So what ends up happening now is you get this, the whole, to find the whole you're going to, whatever term cancel, you're going to set it equal to 0 and solve. So what term canceled here? What term canceled? So I'm going to set that equal to 0. So x plus 7 is equal to 0, which means x is equal to what? Negative 7. So the x-coordinate, the whole is a point. This is a point. So it must be written as a point. So we have the x-coordinate. How do you find the y-coordinate? Plug it back into the reduced equation. So you're going to evaluate the reduced equation at f of negative 7. So plug in negative 7, you get negative 7 minus 8 over negative 7 minus 4. What's negative 7 minus 8? Negative 15. What's negative 7 minus 4? Negative 11, right? So where does the whole occur at? Well, the x-coordinate is negative 7. The y-coordinate is 15 over 11. It becomes positive because you're dividing by two negatives. And then the last step is to find the vertical asymptote. How do you find the vertical asymptote? Well, now that we found there was a hole here, we canceled out the hole, you can look at your reduced form and set the denominator equal to 0. So to find the vertical asymptote, you say that x minus 4 is equal to 0. X is equal to what? 4. This right here, the vertical asymptote, is always a line. And because it's a line, you should always write it as x equals something. You need to have it as x equals something. Don't just put a 4. It should always be written as x equals. So that's what you did, yes?